Welcome to Let Us Crack GATE and ESE ME. This is K. Mameshwarao. Unacademy GATE offline center is coming to Delhi. Classroom batch for GATE 2024 and classroom batch for GATE and ESE 2024. Top indicators for GATE and ESE in India. 100% syllabus in time completion guaranteed. Unlimited access, 70 plus tests as per GATE level. For more details, you can contact this number. Existing plus and iconic subscribers, 50% discount. Learners in other coaching institutes, 50% discount. First 50 enrollments, 33% discount, and discounts based on merit. GATE ranker less than 1000 or PSC interviews appeared or mains interview appeared, you will get 20% discount. Unacademy is announcing Udaan batch and Buniyaad batch for GATE 2024 and 25. Batch commences from February 10th. Unacademy is announcing Udaan batch, one batch for all, GATE, ESE and CSE mains. Batch commences from February 10th. Unacademy is announcing Buniyaad batch, one batch for all, GATE, ESE and CSE mains 2025. Unacademy is announcing Ignite batch for GATE 2024. Unacademy is announcing Foundation batch for GATE ESE 2025. Save up to 42% on your GATE and ESE subscription. Which question, Rana? Which question? Observe. Complex variable. If f of z is y of 1 plus x square plus x square. Rana, that question is correct. It is a closed curve. Okay. Triangle is a closed curve. That's why we have verified the vector. Vector has three components. Therefore, Stokes theorem is applied. Yes, that is 100% correct. I have taken projection on xy plane. Without projection also you can able to solve, because there is a constant in the integrand. So you write area of the equilateral triangle formula. Area of the equilateral triangle formula. Then solve. Same answer will come. Rana, whenever you are going to apply projection rule, you can project on xy plane or yz plane or zx plane. Any one of the coordinate planes you can project. Okay, na? It is not the rule that you have to project on xy plane. You can project either on xy plane or on yz plane or on zx plane. Depending on the projection, you have to write your projection rule. If it is xy plane, you have to write dx dy by modulus of n cap dot k cap in the place of ds. If it is yz plane, you have to write dy dz by modulus of n cap dot I cap. If it is xz plane, then you have to write dx dz by modulus of n cap dot j cap. Okay, na? They never mention in the question, man. Everything if they mention, what you will do? Are you going to substitute? Nothing will be mentioned. You have to get that idea. Either you have to go by xy plane or yz plane or zx plane. Only by practice you can able to solve. Come to the problem. F of z is y of 1 plus x square plus I into y square plus 2y into x. Simple. You write real part and imaginary part. F of z is nothing but u plus I vina. What is real part? Y plus yx square plus x square plus I into xy square plus 2xy. Now u is y plus yx square plus x square. V is xy square plus 2xy. Y plus yx square plus x square, xy square plus 2xy. Understood? Ux. Uy. Vx. Vy. Now observe here. Tomorrow also same timing, 8:30 to 12. Okay. Ux equal to Vy. Clearly Ux equal to Vy for all values of z. What about Uy and minus Vx? Uy is 1 plus x square. Uy equal to minus Vx. When you equate, Uy is 1 plus x square minus Vx is y square plus 2y. Do one thing. 1 plus x square must be equal to minus y square minus 2y. Use the options. In first option, what is z? Z value 0. Okay na? 0. First option, z equal to 0. Z equal to 0 means x equal to 0, y equal to 0. In the above equation, LHS is 1, RHS is 0. 1 not equal to 0. That's why option A is eliminated. Next, second option. Second option, z equal to 1. Z equal to 1 means x is 1, y is 0. When you put x value 1 in LHS, you are getting 2. RHS 0. 2 not equal to 0. That's why option B is eliminated. Next, option C. Z equal to I. X value 0, y value 1. Put x is 0. LHS is 1. RHS is minus 1 minus 2 minus 3. 1 not equal to minus 3. Option C is eliminated. Option D is z equal to minus I. X equal to 0, y equal to minus 1. Put x equal to 0 here, 1. Put y equal to minus 1 here. Minus 1 plus 2, 1. 1 equal to 1. Last option is satisfying the other CR equation. Last option is satisfying the other CR equation. LHS equal to RHS by substituting z equal to minus I. At z equal to minus I, the function is differentiable. At z equal to minus I, the function is differentiable. Next problem. E power 1 by z minus 1 whole square dz. E power 1 by z minus 1 whole square dz. Observe here, the curve is mod z equal to 2. Mod z equal to 2. So z equal to 1 lies inside. E power 1 by z means z equal to 0 is essential singular. that is also lies inside. So we have to calculate residue of f of z at z equal to 0 as well as at z equal to 1. We have to calculate the residue of f of z at z equal to 0 as well as at z equal to 1. Understood? Now do one thing. You use expansion model. 1 by z plus 1 whole square e power 1 by z by z minus 1 whole square can be written as e power 1 by z by 1 minus z whole square. Okay na? That can be written as 1 minus z whole power minus 2 into e power 1 by z. 1 minus z whole power minus 2 can be written as 1 plus 2z plus 3z square plus 4z cube plus and so on. E power 1 by z is 1 plus 1 by z plus 1 by z square by 2 factorial plus 1 by z cube by 3 factorial and so on. Now 1 multiplied with this expansion, you will get same expansion. Observe 1 plus 1 by z plus 1 by 2z square plus 1 by 6z cube plus and so on. 1 by z square by 2 is 1 by 2z square na? Akhil. Now 2z multiplied with 1, 2z into 1, 2z into 1, 2z plus 2z into 1 by z, 2z into 1 by 2z square, 2z into 1 by 2z square, 1 by z, 2z into 1 by 6z cube, 1 by 3z square. Okay na? And so on. Next, 3z square multiplied with 1. 3z square multiplied with 1, 3z square, 3z square multiplied with 1 by z, 3z, 3z square multiplied with 1 by 2z square, 3 by 2, 3z square multiplied with 1 by 6z cube, 1 by 2z and so on. Next, 4z cube multiplied with 1, 4z cube, 4z cube multiplied with 1 by z, 4z square, 4z cube multiplied with 1 by 2z square, 2z, 4z cube multiplied with 1 by 6z cube, 4 by 6 and so on. Now residue is nothing but coefficient of 1 by z. Residue is nothing but coefficient of 1 by z. What is coefficient of 1 by z? Here we have 1 by z term, here we have 1 by z term, here we have 1 by z term. Next here 4 by 4z cube by 1 by 6z cube na. Next term 1 by 24z power 4. 4z cube multiplied with 1 by 24z power 4 is, you will get here 4 6 ja 24 na, 1 by 6z and so on. Now verify 1 by z term, here 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 1 by z term. Therefore 1 plus 1 plus 1 plus 1 plus 1 by 2 plus 1 by 6 plus and so on. This is nothing but 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus and so on. This is nothing but e power. It is expansion of e power z at z equal to 1. E power z expansion at z equal to 1. E. This is nothing but E. Okay na? Therefore, by Cauchy residue theorem, the value of integral is 2 pi I into residue E. 2 pi I E. Answer is 2 pi I E. Got it? Next problem. Let f of z is 1 by 1 minus z square. The coefficient of 1 by z minus 1 in Lorentz series expansion of f of z at z equal to 1. We have to find out coefficient of 1 by z minus 1 in Lorentz series expansion of Sharma. I have taken complete function. In that complete function, coefficient of 1 by z I have calculated. Next one, 1 by 1 minus z square. One by 1 minus z square. If it is 1 by 1 minus z square, you can write minus 1 by z square minus 1. Sir, this can be written as minus 1 by z minus 1 into z plus 1. Z minus 1 into z plus 1. We have to find out the coefficient of 1 by z minus 1 in Lorentz series expansion of f of z at z equal to 1. Since z equal to 1, therefore z minus 1 equal to 0. Let us take z minus 1 equal to t. If z minus 1 equal to t, z equal to t plus 1. Convert your function in terms of t. Minus 1 by z minus 1 is t. Z plus 1 is z plus 1 is t plus 2. Now take 2 common in denominator. Minus 1 by 2t of 1 plus t by 2. That is minus 1 by 2t into 1 plus t by 2 whole inverse. 1 minus t by 2 plus t by 2 whole square minus t by 2 whole cube and so on. Minus 1 by 2t plus 1 by 2 square minus t by 2 cube plus t square by 2 power 4 and so on. That is minus 1 by 2 into z minus 1. 1 by 2 square, z minus 1 by 2 cube, z minus 1 whole square by 2 power 4 and so on. Now coefficient of 1 by z minus 1 is, coefficient of 1 by z minus 1 is this term minus 1 by 2. So final answer is minus 1 by 2. Next problem. The value of contour integral cos hz by 4z square plus 1 dz, cos hz by 4z square plus 1 dz, where the circle is mod z equal to 1, unit circle, mod z equal to 1, unit circle, four z square plus 1, the poles are four z square plus 1 equal to 0. 4z square plus 1 equal to 0. Therefore, 4z square equal to minus 1, z square equal to minus 1 by 4, that is plus or minus I by 2. I by 2 lies inside. Minus I by 2 is also lies inside. Both I by 2 and minus I by 2 lies inside. We have to calculate residue at I by 2 as well as minus I by 2. Residue of f of z at z equal to I by 2 is, limit z tends to I by 2, z minus I by 2 multiplied with cos hz by 4 times of z minus I by 2 into z plus I by 2. As most of the students will forget to write this 4. Okay na? Please observe, it is 4z square. That's why you have to write 4. Z minus I by 2, z minus I by 2 cancel. Now cos h I by 2 by cos h I by 2 by 4 times of I by 2 plus I by 2 is 4i. Cos of h I by 2, cos of h I by 2 by 4i. Keep like that. Next, residue of f of z at z equal to minus I by 2. Residue of f of z at z equal to minus I by 2. Limit z tends to minus I by 2, z plus I by 2 into cos hz by 4 times of z plus I by 2 into z minus I by 2. Z plus I by 2, z plus I by 2 cancel. Cos h of minus I by 2 by minus I minus 4i. Cos of minus theta is cos theta only. Cos h of minus theta is cos h theta only. Cos h I by 2 by minus 4i. Okay na? Now finally the value of integral is 2 pi I into sum of residues. Final answer is 0. F of x plus iy equal to f of z equal to u plus iv be an analytic function defined in the complex plane 2u square plus 3v square equal to 1, then f is constant or f of z equal to kz or u of xy equal to cos x plus y by root 2. V of xy is cos sin x minus y by root 2. Please observe. Actually, it is a problem designed on Picard's theorem. Picard's theorem, it was XE 2007 GATE question. Okay, na? As per Picard's theorem, if the function defined from complex plane to complex plane be a non-constant analytic function, then the image of f is either whole in complex plane or C minus a single point. Okay, na? Complex plane minus single point or whole complex plane. In this problem, it is given that f is f means u plus iv, f of z equal to u plus iv is defined and analytic on complex plane satisfying 2u square plus 3v square equal to 1. So 2u square plus 3v square equal to 1 is not same as C or C minus single point, which is contradicting our Picard's theorem, which is not satisfying the above statement C or C minus a single point. It is like an ellipse. 2u square plus 3v square equal to 1 can be written as ellipse form. Therefore, you can understand that our statement is contradicting Picard's theorem, which is contradicting Picard's theorem, Since it is contradicting Picard's theorem, you can understand that it is not non-constant function. What is Picard's theorem? If it is a non-constant analytic function, okay na? So you got contradiction means 100% it is not non-constant. Not non-constant means 100% constant. Therefore, f of z is a constant function. So finally we found that f of z is a constant function. F of z is a constant function is given in first option. In remaining cases non-constant functions, therefore B is eliminated, C is eliminated, D is eliminated. Only first option is right. Next problem. F of z equal to u plus iv is an analytic function. U minus v equal to x minus y whole cube plus kxy into x minus y. Then k, the value of k is. Excellent problem. Generally, when real part of analytic function is given, we are going to use CR equations. When imaginary part of analytic function is given, we are going to use CR equations. Here, u minus v is given. That's why we are going to apply one rule. Sir, if the function is analytic, both real and imaginary part satisfies harmonic condition, two-dimensional heat equation. That's why I am going to apply Laplace equation condition to get the value of k. If the function is analytic, u and v satisfies harmonic condition. If u and v are harmonic, then f of z equal to u plus iv is analytic. I am going to use that condition. Before that, simple work we have observed. F of z is u plus iv. I into f of z is minus v plus iu. 1 plus I into f of z is u minus v plus I into u plus v. Let us assume u minus v is capital U. U plus v is capital V. 1 plus I into f of z is capital F of z. Okay na? Now small u minus small v is provided. Small u minus small v is nothing but capital U. So this is provided. If f of z is analytic, u satisfies two-dimensional heat equation. U xx plus uyy equal to 0. I am going to use this condition. Okay na? Now capital U is x minus y whole cube plus kx square y minus kxy square. That is nothing but x cube minus y cube minus 3x square y plus 3xy square plus kx square y minus kxy square. Finally, x cube minus y cube plus k minus 3 into x square y plus 3 minus k into xy square. Calculate ux and uxx. 3x square k minus 3 into 2xy, 3 minus k into y square, uxx 6x plus 2k minus 6 into y plus 0. Called it equation 1. Okay na? Now calculate uyy. First uy. Uy is minus 3y square plus k minus 3 into x square plus 3 minus k into 2xy next uyy minus 6y plus 0 plus 6 minus 2k of x. Okay na? uxx plus uyy equal to 0. Here 6x minus 6y plus here 2k minus 6, here 6 minus 2k, 2k minus 6 and 6 minus 2k, 2k minus 6 into y, understood? Now do one thing. Here we have 6x. Here we have 6 minus 2kx. 6 plus 6 minus 2k of x plus y into 2k minus 6. 6 into minus 1 minus 6 equal to 0. Therefore, 12 minus 2k equal to 0. 2k equal to 12, therefore the value of k is 6. Finally, the value of k is 6. When k equal to 6, the real part and imaginary part satisfies harmonic function condition. The function is analytic for k equal to 6. 6 is the correct option. Okay na? Otherwise, put k value from the options one by one, verify CR equations. That also consumes time. The best method is harmonic function only. Okay na? Next problem. Sine power 4z by z plus 4 whole cube. Our job is to calculate residue. A residue of f of z at z equal to minus 4. Residue of f of z at z equal to minus 4. Observe here. Residue of f of z at z equal to minus pi by 4. That is 1 by 2 factorial d square by dz square of z plus pi by 4 whole cube into sine power 4z by okay na? Now not u by v method. क्या किधर से आया जी? हाँ? z plus pi by 4 whole cube, z plus pi by 4 whole cube cancel. Differentiate 2 times. 1 by 2 into d by dz of, when you differentiate sine power 4z, 4 sine cube z, limit z tends to minus pi by 4. Differentiation of 4 sine z cube is 4 sine cube z is 4 into 3 sine square z into differentiation of sine z cos z. 1 minute. Here one correction is there. See, when you differentiate sine power 4z, immediately you have to write differentiation of sine z cos z na. Here we have to apply product rule na. 1 by 2 of 4 sine cube z into minus sine z plus cos z into differentiation of 4 sine cube z 12 sine square z into differentiation of sine z is cos z. Now, when z is tending to minus pi by 4, you will get 1 by 2 of minus 4 sine power 4z 1 by root 2 whole power 4, that is 1 by 4 minus 4 by 4 minus 4 by 4 plus 12 into 1 by 2 into 1 by 2 1 by 4 4 3 ja 12, here 4 4 cancel, minus 1 3 minus 1 is 2, 1 by 2 into 2, the result is 1. Okay na? Residue is 1. Understood? Next. The integral z cube into e power z by z minus 1 whole cube dz along the curve mod z equal to pi by 2. Along the curve mod z equal to pi by 2 oriented counterclockwise. Oriented counterclockwise. Z equal to pi by 2. 1.57. So 1 lies inside. Therefore, you have to calculate residue at 1. Otherwise, you can apply integral formula also. Okay na? Amit, sin z by z, that method is not applicable. Okay na? Observe here. Z cube into e power z by z minus 1 whole cube dz. Observe. Integral. Now, I am comparing this problem with f of z by z minus z naught whole power n plus 1. When I compare this one with this, you can go for integral formula. 2 pi I by n factorial into f power n of z naught. Here 2 pi I by 2 factorial into f double dash of 1. 2 pi I by 2 factorial is pi I d by d square by dz square of z cube into e power z at z equal to 1. Okay na? Now pi I into d by dz of z cube into e power z plus e power z into 3z square at z equal to 1. Now pi I of differentiation of z cube into e power z cube into e power z plus e power z into 3z square plus e power z into 6z plus 3z square into e power z at z equal to 1. That is pi I of, when z is 1, it is e, it is 3e, it is 6e, next 3e, finally 9 plus 13 pi IE, 13 pi IE. Understood? It is not residue. I have not applied residue theorem. I have applied integral formula. That is the final answer. The function z minus sin z by z cube at z equal to 0, pole of order 3 or pole of order 2 are essential singular or removable singular. Z minus sin z by z cube. There is no negative powers of z. All are positive powers of z only. That's why z equal to 0 is a removable singular point. Z equal to 0 is removable singular point. One minus e power minus z by z. 1 minus e power minus z by z. One minus z plus z square by 2 factorial minus z cube by 3 factorial and so on by z. That is 1 minus 1 plus z minus z square by 2 factorial plus z cube by 3 factorial and so on by z. Plus 1 minus 1 cancel. Let us take z common and cancel. You'll get 1 minus z by 2 factorial plus and so on. There is no negative powers of z. Therefore, z equal to 0 is a removable singular point. F of z is mod z, g of z is z bar. F of z is mod z and g of z is z bar. Using CR equations, choose the correct answer. First I am taking f of z. U plus IV equal to square root of x square plus y square. U is square root of x square plus y square. V is 0. Now ux is 1 by 2 root x square plus y square into 2x. X by root x square plus y square. Uy is 1 by 2 root x square plus y square into 2y. Y by root x square plus y square. Vx is 0, Vy is 0. If you verify CR equations are not satisfied. CR equations are not satisfied. Therefore, F is not analytic. F is not analytic. Sir, what about G? Here G is Z bar. Z bar is nowhere analytic na. U plus IV equal to X minus IY. U is X. V is minus Y. Ux is 1. Vy is minus 1. Ux not equal to Vy. CR equation is not satisfied. Therefore, G of Z is not analytic. Because 1 and minus 1 are not equal at any point. So it is neither F is analytic nor G is neither F is analytic nor G is analytic is the correct option. Neither F nor G. Next one. F of Z is Z square into Z bar. Z square into Z bar. F of Z is Z square into Z bar. U plus IV. Do one thing. You write Z square into Z bar like this. Z into Z bar. Z is X plus IY. Z bar is X square plus Y square. X into X square is X cube. XY square plus I into X square Y plus Y cube. U is X cube plus XY square. X square plus 3y square. Please observe. At Z equal to 0, X is 0, Y is 0 na? At Z equal to 0, Ux is 0, Uy is 0, Vx is 0, Vy is 0. CR equations are satisfied. The function is differentiable at Z equal to 0. F of Z equal to Z square into Z bar is differentiable at Z equal to 0. Hello, it is not analytic because in the neighborhood CR equations are not satisfied. That's why it is only differentiable. It is not analytic at Z equal to 0, but it is differentiable at Z equal to 0. It is differentiable at Z equal to 0, but not analytic at Z equal to 0. Observe here. It is differentiable but not analytic. It is differentiable but not analytic is the correct option. Next problem, z plus 4 by z plus 1 into z minus 2 whole cube dz along the contour oriented anti-clockwise. Z plus 4 by z plus 1 into z minus 2 whole cube along the contour modulus of z minus of 1 plus I equal to 2. Here z minus of 1 plus I is nothing but 1 comma 1 is the center and radius 2 units. 1 comma 1 is the center and radius 2 units. One comma 1 center means x minus 1 whole square plus y minus 1 whole square equal to 2 square. Observe, one singular point is z equal to minus 1. Z equal to minus 1 means x value minus 1, y value 0. Four plus 1, 5 greater than 4. LHS is greater than RHS, therefore it lies outside C. Another singular point, z equal to 2, x value to 2 minus 1 whole square plus 0 minus 1 whole square, 1 square plus 1 square, that is 2, 2 less than 4, therefore it lies inside. Okay na? One singular point lies outside C, another singular point lies inside C. Z equal to 2 lies inside C. Therefore, I am writing the given integral in the form of z plus 4 by z plus 1 by z minus 2 whole cube. I would like to apply integral formula. This is f of z. F of z by z minus 2 whole cube dz. That is 2 pi I by 2 factorial into, this is f of z na, f double dash of 2. That is pi I. We have to differentiate f of z 2 times. First time d by dz of denominator is u by v rule, z plus 1 whole square, z plus 1 into 1, z plus 4 into 1, that is pi I of z plus 1 minus z minus 4 is minus 3, minus 3 by z plus 1 whole square at z equal to 2, continuation, pi I into differentiation of minus 3 by z plus 1 whole square, minus 3 into minus 2, 6 by z plus 1 whole cube, at z equal to 2, 6 by z plus 1 whole cube at z equal to 2, 6 by 2 plus 1, 3 cube is 27, 6 by 27, after cancellation 2 pi I by 9, final answer is 2 pi I by 9. Plus 2 pi I by 9. 2 pi I by 9 Observe, the complex number k and a complex variable z and the complex function z plus k whole square. Please observe, z square, z cube or z power 4, z power any positive integer, z plus k whole square or z plus k whole cube or z plus k power any positive integer. It is always analytic for all values of k. It is analytic. Analytic for all values of k is the correct option. In the Lorentz series expansion of f of z equal to 1 by z cube minus z power 4 at z equal to 0 in the region mod z greater than 1. Mod z greater than 1 is given. Region of convergence is provided. 1 less than mod z. 1 by mod z less than 1. Now the function is 1 by z cube minus z power 4. I require 1 by z term. Therefore, I am writing minus 1 by z power 4 minus z cube. Take z power 4 common. 1 minus 1 by z will come. That is minus 1 by z power 4 multiplied with 1 minus 1 by z whole inverse. Minus 1 by z power 4 1 plus 1 by z plus 1 by z square plus 1 by z cube plus and so on. Minus 1 by z power 4 minus 1 by z power 5 minus 1 by z power 6 minus 1 by z power 7 and so on. We have to find out. Okay, series starts from minus 1 common, 1 by z power 4 z power 5 and so on means sigma 1 by, when n equal to 0 it is z power 4. 1 by z power n plus 4 minus 1 by z power n plus 4 is the correct option. Next problem. This was given in 2016. Till now, whatever problems we have solved, all are PYQs of XU only. Next problem. This is previous GATE question, not for XE, other branch. Observe. 1 by 1 minus z about z equal to 1 by 4. We have to find out radius of convergence. See, radius of convergence is nothing but the shortest distance between z naught and closest singular point. Sir, here what is z naught? Z naught is 1 by 4. What is singular point? Z equal to 1. Z equal to 1 is singular point. Z equal to 1 by 4 is z naught. So what is the distance between z equal to 1 and z equal to 1 by 4? What is shortest distance between 1 by 4 and 1? 3 by 4. That is radius of convergence. Radius of convergence is nothing but the shortest distance between z naught and closest singular point of f of z. Why we have mentioned closest singular point? Suppose if you have two singular points, in those two singular points you have to calculate distance between z0 and first singular point and second singular point. Which one is closest, nearest? That is the answer. Here z0 is 1 by 4, singular point is 1, therefore radius of convergence is the distance between modulus of 1 by 4 and 1, 3 by 4. Next problem, let C denotes the set of complex numbers and I square equal to -1. Let gamma be the positively oriented circle mod z equal to 1, where S is a set such that z belongs to complex plane, 0 less than mod z less than 2. Means a circle with center 0 and radius 2. Circle with center 0 and radius 2. If the function f is from S to C is analytic in S and f of z is given by 1 by 8 z square plus 7 by 2 z plus sigma n equal to 0 to infinite a n into z power n, then the value of the contour integral, 1 by pi I integral gamma. Integral gamma means gamma is a unit circle. Do one thing. This is nothing but 1 by pi I integral gamma. Gamma means mod z equal to 1 e power z by cos z dz plus integral mod z equal to 1 f of z dz. What is f of z? 1 by 8 z square plus 1 by 7 z plus sigma n equal to 0 to infinite. Okay na? Observe here, observe carefully. 1 by pi I of here e power z by cos z dz. What are the singular points of cos z? Cos z, z equal to pi by 2, plus or minus 3 pi by 2 and so on. Because for cos z singular points are 2n plus or minus 1 into pi by 2. Anyhow, these are all lies outside mod z equal to 1. If the singular points, all the singular points are lies outside the closed curve, then the value of integral is 0. Plus, come here, this is a polynomial. What he has given? 1 by 8 z square plus 1 by 7 z, 2 by 7 z, 7 by 2 z. 7 by 2z plus and so on. Here he has provided indirectly residue. This is residue na. 7 by 2 is coefficient of 1 by z, that is residue. Therefore the value of this integral is 2 pi I into 7 by 2. 2 pi I into 7 by 2, because coefficient of 1 by z is 7 by 2. Coefficient of 1 by z is 7 by 2. Therefore, that is residue. 2 pi I into residue E is the value of this integral. Bracket close. That is 1 by pi I into 2 pi I. 2 pi I by pi I into 7 by 2. Pi I cancel, 2 to cancel. Final result is 7. Final answer is 7. Next, z bar into e power minus mod z whole square, where z bar is complex conjugate of z, then it is differentiate on, the function is differentiable on which region? Okay na? Now observe carefully. F of z is z bar into e power minus mod z whole square, that is u plus iv equal to z bar is x minus iy, e power minus of x square plus y square, x into e power minus x square minus y square minus I y into e power minus x square minus y square. Okay na? Here u is v is u is x into e power minus x square minus y square, v is minus y into e power minus x square minus y square. Now ux x into e power minus x square minus y square into minus 2x plus e power minus x square minus y square into 1, that is e power minus x square into e power minus y square into minus 2x square plus 1. Now Vy, I am talking about Vy. Minus y into e power minus x square minus y square into minus 2y plus e power minus x square minus y square into differentiation of minus y is minus 1, that is e power minus x square minus y square minus 1 plus 2y square minus 1 plus 2y square. Okay na? Please observe, ux equal to vy is possible. Only when 1 minus 2x square equal to minus 1 plus 2y square. Okay na? 2x square plus 2y square equal to 2. X square plus y square equal to 1. Sir, x square plus y square equal to 1 means mod z equal to 1 na? Actually mod z whole square equal to 1. Unit circle unit circle. Therefore correct answer is mod z equal to 1. Got it? Next problem, excellent problem. The function is analytic with a simple pole at z equal to 1. With a simple pole at z equal to 1 and a double pole at z equal to 2. At z equal to 1 you have simple pole, at z equal to 2 you have double pole, and residues are 1 and minus 2 respectively. F of 0 equal to 0, f of 3 equal to minus 3 by 4, and f is bounded as z tends to infinite. Sir, f is bounded as z tends to infinite. F is bounded as z tends to infinite. F is bounded as z tends to infinite means there is no positive power subject. Given that f is bounded as z tends to infinite, conclusion, therefore there is no positive power subject. If there is a positive power object, when z is tending to infinite, that value become infinite, then the function is unbounded. That's why there is no positive power subject. Only constant term will be there or negative power subject will be there. There is no positive power subject. Now come here. At z equal to 1 you have simple pole. At z equal to 2 you have double pole. Therefore compulsory your function. Given that a simple pole at z equal to 1 and a double pole at z equal to 2. Therefore, our function f of z will be in the form of constant term plus a1 by z minus 1, because z equal to 1 you have a simple pole, z equal to 2 you have a double pole. Double pole means compulsory a2 by z minus 2 plus a3 by z minus 2 whole square because of double pole. Okay na? A1 is residue of f of z at z equal to 1. A2 is residue of f of z at z equal to 2. Sir, in the data they have provided residues of f of z at z equal to 1 is residue of f of z at z equal to 1 is 1. Residue of f of z at z equal to 2 is minus 2. That is also provided in the data. Therefore, our function is, therefore, f of z is a naught plus 1 by z minus 1 minus 2 by z minus 2 plus a 3 by z minus 2 whole square called it equation 1. Okay, na? Now they have provided f of 0 equal to 0. F of 0 equal to 0. Therefore, 0 equal to a naught plus 1 by minus 1 minus 2 by minus 2 plus a3 by 0 minus 2 whole square is 4. Please concentrate. 1 by minus 1 plus 1 cancel. So a naught 4a naught plus a3 equal to 0. Called it equation 2. 4a naught plus a3 equal to 0. Next, f of 3 equal to minus 3 by 4. Minus 3 by 4 equal to a naught plus 1 by 3 minus 1 2 minus 2 by 3 minus 2 1 3 minus 2 1 plus a3 by 3 minus 2 whole square 1. A naught plus a3 equal to minus 3 by 4 plus 2 minus 1 by 2. LCM 4 plus 8 minus 2 3 by 4 8 minus 5 3 by 4 called it equation 3. A naught plus a3 equal to 3 by 4. 4a naught plus a3 equal to 0. From 2 and 3, a naught equal to minus 1 by 4. Okay, na? A naught equal to minus 1 by 4. A3 equal to 1. Therefore, f of z is minus 1 by 4 plus 1 by z minus 1 minus 2 by z minus 2 plus 1 by z minus 2 ka whole square. That is finally our function. Minus 1 by 4 plus 1 by z minus 1 minus 2 by z minus 2 plus 1 by z minus 2 whole square. Understood? Very conceptual, beautiful problem. Next problem. This is also excellent question, but it consumes time. But the value of integral cot pi z by z minus I whole square, cot pi z by z minus I whole square dz, where C is the contour, 4x square plus y square equal to 2, then the value of I is not small I, it is not iota, it is integral. The value of integral is, please observe, integral cot pi z by z minus I whole square dz. Okay na? Observe here, the singular points are sin pi z equal to 0, z minus I whole square equal to 0, z equal to I is a pole of order 2. Sin pi z equal to 0 means sin pi z equal to sin n pi, pi z equal to n pi, z equal to n. So z equal to 0 plus or minus 1 plus or minus 2, like that. Now we have to check whether the singular points are inside the closed curve or outside the closed curve, which one lies inside, which one lies outside. So first identify the curve. 4x square plus y square equal to 2. One minute. Two x square plus y square by 2 equal to 1. X square by 1 by 2 plus y square by 2 equal to 1. X square by 1 by root 2 whole square plus y square by root 2 whole square equal to 1. It represents an ellipse. In our problem, 0 lies inside. I also lies inside because it is root 2i na. Root 2i means 1.414i. That's why it is an ellipse where 0 lies inside and I also lies inside. We have to calculate residue at I as well as 0. Now, residue of f of z at z equal to 0. What is f of z? Cot pi z by when z is tending to 0, numerator is non-zero but denominator is 0. That's why you can write limit z tends to 0 cos pi z by differentiation of denominator differentiation of sin pi z is pi cos pi z. When z is tending to 0, numerator is 1, denominator is 0 plus I square is minus 1, minus 1 into pi minus pi. Finally, minus 1 by pi. Residue of f of z at z equal to 0 is minus 1 by pi. Next. Residue of cot pi z by z minus I whole square at z equal to I is limit z tends to I 1 by 1 factorial d by dz of z minus I whole square into cot pi z by z minus I whole square. Z minus I whole square, z minus I whole square cancel. Differentiation of cot pi z is minus pi cosec square pi z minus pi cosec square pi I minus pi by sin square pi I minus pi by sin square pi I can be written as I sin h pi whole square. Pi by sin h square pi. Pi by sin h square pi. Therefore, the value of integral is 2 pi I into sum of residues. One residue is minus 1 by pi, another residue is pi by sin h square pi. That is the final answer. Two pi I into pi by sin h square pi minus 1 by pi. Next problem. Next problem. For the positively oriented unit circle, for the positively oriented unit circle, integral 2 into real z by z plus 2, 2 into real z by z plus 2, here what is real z? When the circle is unit circle, okay na? Z plus Z inverse is nothing but Z plus 1 by Z equal to 2 cos theta. Z square plus 1 by 2Z is cos theta. Z square plus 1 by 2Z equal to cos theta. Cos theta is nothing but real Z. Now the integral 2 into real z by z plus 2 dz, real z, z square plus 1 by 2z by z plus 2. 2 cancel. Z square plus 1 by z into z plus 2 dz, where circle is mod z equal to 1. Here z equal to 0 lies inside, z equal to 2 lies outside. Now that's why I am writing integral z square plus 1 by z plus 2 by z dz. This is f of z. F of z by Cauchy's integral formula, it is equal to 2 pi I into f of 0, because denominator is z, z equal to 0 lies inside. That's why 2 pi I into f of 0, 0 plus 1 by 0 plus 2. That is 2 to cancel, pi I. Finally, the answer is pi I. Next problem. The function f of z equal to x square plus iy square and g of z equal to x square plus y square plus ixy at z equal to 0. We have to check whether f and g are analytic or not. First function f of z is x square plus iy square u is x square, v is y square, ux is 2x, uy is 0, vx is 0, vy is 2y at z equal to 0. Ux is 0, uy is 0, vx is 0, vy is 0. See, at z equal to 0, CR equations are satisfied, but not in its neighborhood. But not in its neighborhood. Therefore, f of z is not analytic at z equal to 0. The function is not analytic at z equal to 0. What about g of z? G of z is x square plus y square plus ixy now u is x square plus y square, v is xy, ux is 2x, vy is x, uy is 2y, vx is y. CR equations are not satisfied. At z equal to 0, CR equations are satisfied. At z equal to 0, ux is 0, uy is 0, vx is 0, vy is 0. Therefore, CR equations are satisfied only at z equal to 0. Only at z equal to 0, but not in its neighborhood. It is differentiable but not analytic. F of z is differentiable at z equal to 0 but not analytic at z equal to 0. Similarly here, g of z is derivable at z equal to 0 but not analytic at z equal to 0. It is differentiable at z equal to 0 but not analytic at z equal to 0. Now, correct option is neither f is analytic nor g is analytic. Neither f nor g is analytic. Understood? Next problem. The coefficient of 1 by z in the expansion of log z by z minus 1 valid in the region mod z greater than 1. Mod z greater than 1. Observe here. Mod z greater than 1 is nothing but 1 less than mod z. 1 by mod z less than 1. 1 by mod z less than 1. The function is log z by z minus 1. Z minus 1 by z whole inverse minus log z minus 1 by z, that is log 1 minus 1 by z is minus 1 by z minus 1 by z square by 2 minus 1 by z square by 3 minus 1 by z power 4 by 4 and so on. Continuation, minus of minus plus, so 1 by z plus 1 by 2 z square plus 1 by 3 z cube and so on and so on. 1 by z plus 1 by 2 z square plus 1 by 3 z cube and so on. Now coefficient of 1 by z is 1. Our job is to calculate coefficient of 1 by z, that is 1. Understood? Next problem. Integral 0 to 2 pi. Integral 0 to 2 pi e power I theta minus I theta e power I theta minus I theta d theta. Please observe. Let us take e power I theta equal to z. If you take e power I theta as z, I into e power I theta d theta equal to dz, d theta equal to dz by I into e power I theta, d theta equal to dz by iz. When e power I theta equal to z, automatically mod z equal to 1, because mod z equal to mod e power I theta. Mod e power I theta is mod cos theta plus I sin theta, that is square root of cos square theta plus sin square theta, that is 1. That is 1. Mod z equal to 1. Therefore mod z equal to 1, unit circle. Curve is unit circle. Understood? The curve is unit circle. So when the curve is unit circle, integral e power I theta is z. 1 minute. E power I theta minus I theta d theta can be written as integral mod z equal to 1 e power z. E power I theta is z, e power minus I theta is z inverse, d theta is dz by ij. Therefore mod z equal to 1 e power z by z square, I z square, dz. So here z equal to 0 is the pole which lies inside, na? Z equal to 0 lies inside or not? Therefore, the integral is 1 by I integral mod z equal to 1 e power z by z square dz. So, I am going to apply integral formula 1 by I into 2 by I by 1 factorial d by dz of f dash z means e power z at z equal to 0. Now 2 pi I by I, 2 pi, differentiation of e power z is e power z from at z equal to 0. That is 2 pi I into e power 0 is 1. Final answer is 2 pi. Final answer is 2 pi. Let f of z is n equal to 0 to 15, n equal to 0 to 15 z power n. Observe here, integral C 1 plus z square plus z power 15 by z minus I whole power 15 dz. Okay, na? Here z equal to I lies inside because our circle is with center I and radius 2. Center I and radius 2. That's why 2 pi I by 14 factorial into d by dz. Now d power 14 by dz power 14. We have to differentiate 14 times. Which one? Function of z. This one, this one. After that, we have to substitute z equal to I. Now, 2 pi I by 14 factorial. When you differentiate this polynomial 14 times, z power 14 become 14 factorial plus z power 15 becomes 15 into 14 factor, that is 15 factorial z, where z equal to I. 1 minute. 2 pi I by 14 factorial. If you take 14 factorial common, 1 plus 15z at z equal to I. Fourteen factorial cancel. 2 pi I into 1 plus 15i. 2 pi I into 1 plus 15i. Final answer is 2 pi I of 1 plus 15i. limit n tends to minus infinite to infinite a n into z plus 1 whole power n be the Laurent series expansion of f of z equal to sin z by z plus 2 z plus 1 sin z by z plus 1, then a minus 2 is, let us take z plus 1 is t, z equal to t minus 1, sin z by z plus 1, sin 1 minus 1 by t, sin 1 cos 1 by t minus cos 1 sin 1 by t, sin 1 cos 1 by t minus cos 1 sin 1 by t, cos 1 by t is 1 minus 1 by t square by 2 factorial plus 1 by t power 4 by 4 factorial minus cos 1 sin 1 by t is 1 by t minus 1 by t cube by 3 factorial plus 1 by t power 5 by 5 factorial and so on. Sin 1 by 2t square, sin 1 by 24 t power 4, cos 1 by t, cos 1 by 60 cube and so on. Sin 1 minus cos 1 by t minus sin 1 by 2t square plus cos 1 by 60 cube plus sin 1 by 24 t power 4 and so on. That can be written as sin 1 minus cos 1 by z plus 1 minus sin 1 by 2 into z plus 1 whole square plus cos 1 by 6 into z plus 1 whole cube plus sin 1 by 24 into z plus 1 whole power 4. Okay na? Now a minus 2 is coefficient of 1 by z plus 1 whole square, that is minus sin 1 by 2 minus sin 1 by 2 answer is minus sin 1 by 2. Observe next problem. Consider the function f of z is e power iz by z into z square plus 1. The residue of f at the isolated singular point in the upper half plane is, first you have to identify singular points. Whichever singular point is in the upper half plane, you have to calculate residue of that function first. Observe here. E power iz by z into z square plus 1. Here z equal to 0, z equal to plus I and minus I are the poles. Which one lies upper half plane? Z equal to I lies upper half plane. Z equal to 0 lies on the real line. Z equal to minus I lies lower half plane. In the problem he has mentioned y greater than 0. Y greater than 0 means should not take y equal to 0. You have to take y greater than 0. Given that y greater than 0, I am talking about first question. Y greater than 0 means z equal to I only. We have to calculate residue at z equal to I. E power I square I into I plus I to I e power minus 1 by minus 2 minus 1 by 2e. So first question is minus 1 by 2e. Next one, sir, what is the value of integral minus infinite to infinite sin x dx by x into x square plus 1? Second question. The value of minus infinite to infinite sin x by x into x square plus 1 dx. This is nothing but, please concentrate, imaginary part of e power iz by z into z square plus 1 dz. That is equivalent to imaginary part of 2 pi I into 2 pi I into, please concentrate, 2 pi I into residue of f of z at z equal to I, upper half plane, plus pi I into residue of f of z at z equal to 0, because z equal to 0 lies on the real line, on the boundary of the curve. Because whenever you are evaluating a real integral f of x dx form, if it lies on the upper half plane, you have to multiply with 2 pi I. Lies on the real line, then you have to multiply with pi I. Please remember, special problem. Okay na? So I require residue of f of z at z equal to 0. That's why I am calculating residue of f of z at z equal to 0. E power I z by z into z square plus 1 at z equal to 0. Limit z tends to 0, z minus 0 into e power I z by z cancel. When z is tending to 0, e power 0 is 1, 0 plus 1, that is 1. Okay na? Now come here, imaginary part of two pi I into minus 1 by 2e plus pi I into 1. Sir, this is imaginary term, this is also imaginary term. Therefore, the answer is 2 pi into minus 1 by 2e plus pi. 2 to cancel, minus pi by e plus pi, that is pi of 1 minus 1 by e. Pi of 1 minus 1 by e is the answer. Pi of 1 minus 1 by e. Yeah, pi of 1 minus 1 by e. Got it? Next problem. Next problem. The coefficient of z minus pi whole square in the Taylor series expansion of sin z by z minus pi. Vineet, to evaluate a real integral, minus infinite to infinite f of x dx is not closed curve. It is not closed curve. That's why we have to apply Jordan's lemma. What is Jordan's lemma? We have to create one artificial closed curve, semicircle gamma and diameter from minus r to r. Yeah, minus r to r is diameter of the circle. Okay na? This is our curve. This is our closed curve. This is a real line. Above real line is upper half, below real line is lower half. Our curve is not below real line, our curve is above real line. That's why upper half plane we have to consider, lower half plane we have to neglect. So in the upper half plane we have one pole, I lies upper half, 0 lies on the boundary. That's why for upper half plane you have to write 2 pi I into residue of f of z at z equal to I, plus for real line it is on the boundary, Therefore, pi I into residue of f of z at z equal to 0. Understood? That is speciality of this problem. Till now, how many problems we have solved? In those problems, we never get pole on the boundary. Here we got a pole on the boundary. Next. The coefficient of z minus pi whole square in Taylor series expansion of sin z by z minus pi. Do one thing. Let us take z minus pi equal to t, z equal to pi plus t. Now the function is sin z by z minus pi. Sin of 180 plus theta is minus sin theta. That is t minus t cube by 3 factorial, t power 5 by 5 factorial and so on by t. That is minus of 1 minus t square by 3 factorial plus t power 4 by 5 factorial and so on, minus 1 plus t square by 3 factorial minus t power 4 by 5 factorial. T is nothing but z minus pi. And so on. We have to find out coefficient of z minus pi whole square. One by 3 factorial, 1 by 6. One by 6 is the answer. Understood? Got it? Now you have break. After that 5 minutes break. two students have take a test consisting true or false questions. To pass the test, students have to answer 3 correctly. Both of them know the correct answer to 2 questions and guess the remaining 3. What is the probability that student passes the test? Please observe. There are 5 questions. Student knows the answer. Student pass the test if they answer 3 questions correctly. So both the students knows 2 questions correctly. So the remaining 3 they guessed. So remaining 3 they have guessed. In the remaining 3 whatever questions they have guessed, in that at least one answer is correct, the student will pass. Okay na? So there are 5 questions. These 2 questions are known. Remaining 3 are guessed. In the remaining 3, they may guess 1 question correctly or 2 questions correctly or 3 questions correctly. What is probability that 3 answers correct? What is the chance of getting 3 answers correctly? Oh, 3 factorial by 3 factorial by 0 factorial into 3 factorial. That is favorable cases. It is true or false question, na? 2 into 2 into 2. So 1 by 8. Okay, na? So what is the probability that 2 answers correctly? Two answers correctly means 3 factorial by 2 factorial by 2 into 2 into 2, because 3 questions, 2 options, either true or false. So 3 by 8. What is the probability that 1 answer correctly? 1 answer correctly. 1 answer correctly in 3 attempts. 1 answer correctly in 3 attempts. 3 factorial by 3 factorial by 1 factorial into 2 factorial by 2 into 2 into 2. 3 by 8. So the chance that they answered correctly is 1 by 8 plus 3 by 8 plus 3 by 8. Probability that they answered correctly. They answered correctly, at least one of them. One by 8 plus 3 by 8 plus 3 by 8. That is 7 by 8. This is not the answer. This is not the answer. What we have to calculate? The probability that only one student passes the test. This is, you have calculated probability that the student pass in the examination. Okay, na? Passing chance is 7 by 8. When student will pass? If he answered at least 3 questions correctly. 2 questions he already knows the answer. For 1 question he has guessed. The guessed answer being correct. 7 by 8. That's why we have to calculate probability that only one student passes the test. Probability that one student passes the test. That means first student pass, second student fail, or first student fail, second student pass. So chance that the student passes the exam is 7/8. Fail the exam is 1/8. 1/8 into 7/8. That is 7/64 plus 7/64. That is 2 times of 7/64, that is 7/32. That is the required probability. 7/32 is the required probability. 7/8 is the probability that the guessed answer being correct. Okay na? Right. Next problem. The probability that a six-sided dice is thrown n times without giving a 6 even ones. Five by 6 whole power n, 5/6 into 1/6 whole power n. Third option, n minus 1 factorial by n factorial into 1/6 whole power n. 1 minus n minus 1 factorial by n factorial into 5/6 whole power n. See, one dice is rolled n times. What is the probability of getting? What is the probability of not getting 6 even ones? Okay, all n times you should not get 6. You have to get other number. Simple. First time, second time and nth time not getting number 6. Not getting 6. It is a throwing die experiment. Chance of getting 6 is 1/6. Not getting 6 is 5/6. 5/6. 5/6. You should not get 6 not even once. So the answer is 5/6 whole power n. Answer is 5/6 whole power n. Next, problem. Let f of x be a continuous and satisfy m less than or equal to f of x less than or equal to capital M in 1 less than or equal to x less than or equal to 10, then integral 1 to 10 f of x into x square dx by integral 1 to 10 x square dx satisfies option A, mu less than or equal to 333 m, 333 mu greater than or equal to capital M, small m less than or equal to mu less than or equal to capital M, small m less than or equal to mu less than or equal to capital M by 333. Observe here, f of x is a continuous curve. Given that small m less than or equal to capital X less than or equal to capital M. Sir, if small m less than or equal to f of x less than or equal to capital M, you can able to write mx square less than or equal to f of x into x square less than or equal to capital Mx square. Yes, integral 1 to 10 mx square dx less than or equal to integral 1 to 10 f of x into x square x square into f of x less than or equal to 1 to 10 capital M into x square dx. Sir, this can be written as m into integral 1 to 10 x square dx less than or equal to integral 1 to 10 x square into f of x dx less than or equal to capital M into integral 1 to 10 x square dx. Now divide by 1 to 10 x square dx, then what will come? Throughout the integral divide by 1 to 10 x square dx, small m less than or equal to 1 to 10 x square into f of x dx by integral 1 to 10 x square dx less than or equal to capital M. Sir, this value is nothing but mu. That's why small m less than or equal to mu less than or equal to capital M. Final answer is small m less than or equal to mu less than or equal to capital M. Since this is mu, that's why third option is correct. Next problem. XC 2011. In a biased die experiment, the random variable x of the outcomes has the following cumulative distribution, then the variance of x is 1, 2, 3, 4, next 5, then 6. It is a biased die. Now, if you prepare the table, probability distribution table, you can understand that x value and capital F of x value. X value 1, 2, 3, 4, 5, 6. At x, capital X is 0.1, capital F of x is here 0.3, here 0.5, here 0.7, here 0.9, here 1. Okay, na? Now, sir, what about small f of x? Density function or mass function, we will say 0.1. See, 0.3 minus 0.1, 0.2, 0.5 minus 0.3, 0.2, 0.7 minus 0.5, 0.2, 0.9 minus 0.7, 0.2, 1 minus 0.9, 0.1. Okay, na? Now we have to calculate variance. To calculate variance, first we have to calculate mean. Expectation of x is sigma x into p of x. 1 into 0.1. Yeah, 1 into 0.1. 2 into 0.2. 2 into 0.2. 3 into 0.2, 4 into 0.2, 5 into 0.2, 6 into 0.1. Simplify this. 3.5. Next, what about expectation of x square? One square into 0.1, 2 square into 0.2, 3 square into 0.2, 4 square into 0.2, 5 square into 0.2, 6 square into 0.1. Simplify this. 14.5. Then variance of x is expectation of x minus expectation of x whole square. 14.5 minus 3.5 whole square. 14.5 minus 3.5 whole square. 12.25. Simplify this. Variance is 2.25. Variance is 2.25. Next problem. Suppose 50% of population of a village, of a city like Orange, and the population like, and 70% of the population like apples, and 40% like both. If a person picked at random who likes at least one of these fruits, what is the probability that the person like oranges, Apurv, in the previous problem, cumulative distribution is given. You require mass function. How to get mass function? 0.3 minus 0.1 is 0.2, 0.5 minus 0.3 is 0.2, 0.7 minus 0.5 is 0.2, 0.9 minus 0.7 is 0.2, 1 minus 0.9 is 0.1. Like that, I have calculated individual distribution. Okay, now come to the problem. Option A, 1 by 8, 5 by 12, 1 by 2, 5 by 8. Solve the problem by using Venn diagram. That is the best method. Whenever data is given in terms of percentage, better to solve the problem by Venn diagram. Oranges, apples. 50% of the population like oranges, 40% like both. So write 40% here, remaining 10% here. 70% like apples, remaining 30 here. Okay, now? Now we have to calculate. See, 40, 30, 70, 70 plus 10, 80. So 80% of the population like any one of the fruit. So remaining 20% neither like oranges nor like apples. Okay, na? Now we have to calculate if the person like at least one of these two fruits, what is the chance that he like oranges? Okay, na? Observe here. He likes at least one of the fruit. At least one of the fruit means 80. He likes oranges means 50. Therefore, 5 by 8 is the required probability. He likes at least one of the fruit. At least one of the fruit means either oranges or apples. That means total 80 people like any one of the fruit. Now, it was given in 2011 or 12, XC 2011, 12. Next. If mean and variance of a binomial distribution are 6 and 2 respectively, then the probability of 2 failures is the probability of 2 failures is 4 into 2 by 3 whole power n, 4 into 2 square by 3 power 7, 17 into 2 by 3 whole power 7, 17 into 2 square by 3 power 7. Now, mean and variance of binomial distribution is provided. See, NP equal to 6. NPQ equal to 2. Therefore, two by 6. 1 by 3. If Q is 1 by 3, what is P? 2 by 3. See, NP equal to 6 na? P equal to 2 by 3. P equal to 2 by 3. 2n equal to 18. N equal to 9. The value of n is 9. P is 2 by 3, Q is 1 by 3. The value of n is 9, P is 2 by 3 and Q is 1 by 3. Now come to the problem. We have to calculate the probability of exactly 2 failures. Okay na? 2 failures. X counts number of failures. Probability of exactly 2 failures, NC2, P power 2, Q power n minus 2, 9C2, 2 by 3 whole power 2, 1 by 3 whole power 9 minus 2. Simplify this. 9C2 is 9 into 7 by 2 into 1, 9 into 8 by 2 into 1, so 36. 2 by 3 whole square, 4 by 9, 1 by 3 whole power 7, 1 by 3 whole power 7. Simplify this. 9 4 ja 36. So 4 into 1 by 3 whole power 7. Now 4 into 2 square by 3 power 7. 4 into 2 square by 3 power 7 is the answer. 4 into 2 square by 3 power 7. Understood? Next one. 10 chocolates. 10 chocolates are distributed randomly among 3 children. Among 3 children standing in a row. The probability that the first child receives exactly 3 chocolates is option A, 5 into 2 power 11 by 3 power 9, 5 into 2 power 10 by 3 power 9, 1 by 3 power 9, 1 by 3. Observe here. There are 10 chocolates and 3 children. 3 different children. Observe here. First chocolate you can give either to first child or second child or third child. Every chocolate has 3 options. First chocolate you can distribute to any one of the 3 children 3 ways. Second chocolate 3 ways. Third chocolate 3 ways. 10th chocolate 3 ways. So 3 into 3 into 3 into 3, how many times? 3 power 10 ways. Okay na? Now I am going to write favorable cases. What is the chance that first child got 3 chocolates? So there are 10 chocolates. From 10 you select 3 and give it to first child. 10C3 for first child. Remaining how many chocolates are available? 7 chocolates are available remaining. From 10 chocolates you have selected 3 and you have given it to first child. So remaining 7 chocolates are available. 2 children are available. So now first chocolate can be given to either second child or third child 2 ways. Second chocolate 2 ways. 7th chocolate 2 ways. So 2 into 2 into 2 7 times. 10C3 into 2 power 7. Okay na? 10C3 into 2 power 7. Therefore, the required probability is 10C3 into 2 power 7 by 3 power 10. 10C3 into 2 power 7 by 3 power 10. Now simplify this. 10C3 is nothing but 10 into 9 into 8 by 3 into 2 into 1, 2 power 7 by 3 power 10. Now 2 5 ja 10, 3 3 ja 9, 15 8 ja 120, 120 into 2 power 7 by 3 power 10. ఓకేనా? 120 into 2 power 7 by 3 power 10. So 340s. So 40 into, otherwise do one thing, 40 into 2 power 7 by 3 power 9, that can be written as 5 into 2 power 10, 2 cube into 2 power 7, 2 power 10 by 3 power 9, 5 into 2 power 10 by 3 power 9, 5 into 2 power 10 by 3 power 9. Understood? Next. A box contains 10 light bulbs in which 2 are defective. 2 are defective. So 8 are non-defective. 2 bulbs are drawn. 2 are drawn at random. Two are drawn at random, one after the other without replacement. 2 are drawn at random, one after the other without replacement. Two are drawn one after the other without replacement. The probability that both light bulbs, both the light bulbs drawn are non-defective. Option A, 8 by 45, 28 by 45, 16 by 25, 4 by 5. See, there are 10 bulbs in which 2 are defective. Eight are non-defective. 2 bulbs are drawn without replacement one after the other. Eight C2 by 10 C2. 8 into 7 by 10 into 9. 8 into 10, 8 into 7 by 10 into 9. 2 4 ja, 2 5 ja. 28 by 45 is the required probability. 28 by 45 is the required probability. Very good. Next problem. A company records heights of employees. Okay na? Let X and Y. Let X and Y denotes errors in the average height of male and female employees, respectively. Here X follows normal distribution with mean 0 and variance 4. Y follows normal distribution with mean 0 and variance 9. They are independent. X and Y are independent. Then the distribution of Z. Sir, what is Z? X plus Y by 2 is option A, normal distribution with mean 0 and variance 6.5, normal distribution with mean 0 and variance 3.25, normal distribution with mean 0 and variance 2, normal distribution with mean 0 and variance 1. Okay na? First Z is X plus Y by 2. Z is X plus Y by 2. Expectation of Z is expectation of X plus Y by 2. 1 by 2 into E of X plus E of Y. Sir, mean of X is 0. Mean of Y is also 0. Therefore, mean of Z is 0. Mean of Z is 0. Clearly, Z follows normal distribution with mean 0. Next, what about variance? Variance of Z is Z is X plus Y by 2 na? Sir, variance of constant in X is constant square into variance of X. 1 by 4 into variance of X plus Y. Sir, when X and Y are independent, variance of X plus Y is variance of X plus variance of Y. So 1 by 4 of variance of X is 4, variance of Y is 9, that is given in the data. Therefore 13 by 4 is 4 3 ja 12 and 25, 3.25. Therefore Z follows normal distribution. Z follows normal distribution with mean 0 and variance 3.25. Okay na? Now n of 0 comma 3.25 is the correct option. 0 comma 3.25 is the correct option. Okay na? Next problem. 3. 3 fair dice are rolled simultaneously, the probability of getting a sum 5 is option A 1 by 108, 1 by 72, 1 by 54, 1 by 36. Sir, here 3 dice are rolled. Yes, if 3 dice are rolled, n of s is 216. Probability of getting sum 5 when 3 dice are rolled. Sum 5 means 1 2 2, 2 1 2, 2 2 1. Okay na? 1 1 3, 1 3 1, 3 1 1. Any other? No. Number of favorable cases to the event E equal to 6. Therefore, required probability is 6 by 216, 1 by 36. The required probability is 1 by 36. Understood? Next problem. Let X be a Poisson variate, with parameter parameter is what? Lambda equal to 1. Then probability of 2 less than or equal to x less than or equal to 4 is option A 19 by 24E, 17 by 24E, 13 by 24E, 11 by 24E. Understood? Now here lambda equal to 1, we have to calculate probability of 2 less than or equal to x less than or equal to 4. 2, 3, 4. 2, 3, 4. E power minus lambda into lambda square by 2 factorial, e power minus lambda into lambda power 3 by 3 factorial, e power minus lambda into lambda power 4 by 4 factorial. That is e power minus 1 into 1 by 2, e power minus 1 into 1 by 3 factorial means 1 by 6. 1 by 24. E power minus 1 of 24 LCM, 6 4 ja 4 plus 1, 12 plus 4 plus 1, 17 by 24E. Answer is 17 by 24E. Understood? Okay. Tomorrow what I am going to do, I think you have 12 o'clock onwards, Gilsar class is there, right? So no issue. Tomorrow I am going to solve 2020 gate problem, 19, 20, 21, 22. If I solve these 4-year gate questions, you can understand the trend of the questions. Okay, na? If I solve these 4-year papers in all topics, you will get the idea about the trend of the questions. So, day after tomorrow, if you attend XC exam, comfortably you can able to write if you understand what trend of questions were asked in the previous examinations. Okay? Right. Thank you.